Hey, we had Black Friday, and I picked up a lot of these smart Wi-Fi plugs from TP-Link, and they're rather good. You can control them via Alexa, and you can control them via a mobile phone and turn things
For
on and
help
off.
with the question, go to the Help and Feedback
Okay,
section of the Alexa app.
thank you. One of the problems you've got with these is it says on the bottom of the box, it says system requirement, mobile device running iOS 8 or higher, or Android 4.1 or higher, uh, and a Wi-Fi network. So when you try to set these things up, you need to have the Android device or an iOS device, and then when you want to run them after that, you still need that device to control them. So although they are Wi-Fi controlled, they don't actually work from the web, which is a little bit of a restriction. So you can see on the screen here, hopefully, this GitHub account, my GitHub account, in fact. I have a TP-Link Smart Switch web client, and that basically builds out this UI for you. So I'm listing here the devices, and basically I have to go into the settings. I provide a username and password. All the documentation for this is on the TP-Link GitHub page. I provide a username and password. It generates a token for me, and then it builds this UI, which is able to then send messages to the TP-Link API server and determine what devices I have and work out whether they're on or not and receive instruction. So as an example, you can see here, I'm sitting at the moment in my lounge at home, and I can turn my lounge lamp off, and I can turn the table lamp off, and it'll put me into darkness. That's how they work. That's working from the web, and it means that I don't actually need an Android device. I don't need iOS anymore, and I can take my iPhone to work with me and leave my other half with a Windows mobile, and she can still control all those lamps. Of course, if you want to control them in the house, you can say, Alexa, turn off the lounge lamps.
Okay.
And she will. So far so good. What I've done with this is actually built this out using Angular. Now, one of the reasons for that is that it allows you to build quite complex web pages. I'm going to turn the lights back on again. Build quite complex web pages using fairly small and static source. So if I actually go and have a look at the page source for this, you'll see certain instructions in here, things like the repeats. If I find one, let me have a look. Go down through the username and password. In fact, it's here. So device in TP-Link devices, yeah, ng repeat, each one of those, it just builds another one of these and lets me set the state to be powered or not. So I can just, with these few lines, I can have it build this whole repeated element. So the web page itself is actually quite a lot smaller, and Angular combines with a set of script hosted, in this case, off-site again. So I'll have a little look where that is. You can see, yeah, Angular coming in. In fact, it's down the bottom, sorry. Coming in from Google APIs. So I'm using CDN hosting to really bring the size of this thing down. And it combines and runs my local script file, and between the two of them then works out. This is how the screen needs to lay out. Now the reason for doing that and keeping it as small as possible and as static as possible means I put very, very low demand on my web server. The web server itself only has to serve this page, index page, and the script file, and everything else is served by the by CDNs and Google APIs, all built out using Angular logic. So the DOM gets changed by the code. What that means is I can run it on a very, very small web server. So for example, this web server. This is a Wemos D1 Mini Pro. They cost about £8. Less if you're prepared to wait for a long time for shipping. And I can run that on here. Now that is sitting on my network. You can see, in fact, it counting through events here. I'm running an Arduino debugger here. So I'm going to scroll back and find out where the thing lives. It's at 32, so 192.168.32. That is this one. And so if I hit that, you can see this all scrolls by saying, "Hello, we've got some events going on, homepage requests, script requests being done." So and a status request. And that status request actually brought in some additional information about the configuration of this one. So this one is called Blue Light, and you can see that not only do I have the network device list here of my TP-Link devices, which I can still operate from here, but additionally I have the blue light itself here, which I can turn on and off. It in itself, it's not particularly magical, but if you know anything of microprocessors, you know that if I can turn that light on and off, I can do anything with anything that's connected to it. So I could have a servo connected to that fed my cats, I could have something open or close curtains, I could have the colour temperature of a bedside light change, I could have alarms be set off, I could detect foul odours and respond to things. I can do all manner of things with this, basically, as can anybody else. But through this, I'm able to provide this web interface, and then from that I can create my own custom programming around what I want to do with this particular device, but also I can consume the web service from a page that's hosted here, which is then pretending to be an Android app, so that I can ask the TP-Link API what it wants to do with these things and what I've got. So effectively you have this little blue thing, little blue lamp here, turn it on, the blue light pretending to be a web server, or being a web server, but being a very small one, generating code that pretends to be an app running on an Android phone that gets sent to TP-Link and comes back into here. But that is not the end of the things that it pretends to do. So if I look at the alternate web server here, because I'm actually running more than one, I'm also running one on 81, and I look at setup XML, you can see this file gets sent, so it's sending XML version here, and so on. It's a Belkin device. So this little device is now pretending to be a Belkin emulated socket, basically. This is a Wemo socket, which is, of course, not. But it looks like one, and because I can send it this in response to this request for setup XML, it means that I can use Alexa, turn off the blue light, did I call it blue light? I didn't call it blue light, it'd be slight inversion. What did I call it? I did call it. Why are you off? Who do you think you're off already? Oh, look at that, I've already broken that. Wow. Oh, it's upset now. What's it doing? Off into the world of code. Okay. Alexa, turn off the blue light.
Okay.
Thank you. Alexa, turn on the blue light.
Okay.
Yeah. Okay, so Alexa, you can see here the output from the chip. Alexa is able to talk to, is able to talk to this, and she's going to talk to me in a second. And this is able to then respond to
No
that, which means
messages from today.
I know, thank
For
you.
earlier ones, go to the Alexa app.
I will go to the Alexa app. So sitting here, I can see on the device list for Alexa, I have something called blue light. So that's her discovering blue light by asking around for setup XML and discovering that this is a device that's pretending to be a Wemo switch, which of course it isn't. But because she thinks it is, she can add it to this, and now I can control it using voice commands issued to a popular Amazon device. So I now have this pretending to be a smart socket from one company, from Belkin, then actually on a separate web server on the same thing, pretending to be an app or a server which is able to serve an app which is running on a Chrome browser on a Mac, which is pretending to be an Android app, talking to a TP-Link API so that I can turn the lights on and off. That, I think, is what they mean when they say Internet of Things. In this case, it's an internet of people pretending to be things that they're not, which has probably got parallels in the real thing.